Hello, this is Ms. Leva, and for today's lesson, we are going to continue working on similar figures. We did start similar figures out last week, and so we're going to continue with what we learned last week, and we're also going to start applying it to real-world situations. So starting off with our learning objectives, students will know how to solve mathematical and real-world problems involving similar shapes. Students will understand how to apply proportional reasoning to solve real-world problems involving similar figures. And lastly, students will be able to read real-world situations and apply similar figure proportions to solve for missing measurements. So again, it's going to be very similar to some of the stuff that we did last week, but now we're using it in real-world applications. So just a few reminders of some of the stuff that we went over last week. We did have 3 rules in order for shapes to be considered similar. The first rule was that they must be the same shape, but they can be a different size. Their corresponding angles must be congruent, and their corresponding sides must be proportional. And then the little squiggly line is the symbol that represents similar. And then just some vocabulary terms that we've learned last week, just to remind you what they are. Corresponding just means that they are in the same place or the same position. And then our scale factor is the number that you use to multiply by to make a similar shape either larger or smaller. So it's basically when you're increasing or decreasing the size of something, it's the number that you're using to make that shape either bigger or smaller with that number. And then a reminder for the 3 steps to solve for missing sides of similar figures. We did have 3 steps. The first one is to draw the shapes correctly, which may mean that you have to either move them or separate them. So for example, if you had 2 rectangles like this, you may want to stand this one up so that it's facing the correct way that this one is facing. Or when you have the embedded triangles like this, you may want to separate them out. So this is a big triangle, and then there's a small one that's embedded into it, so you would separate that one out. And then step 2, you would want to set up your proportion, and when you do your proportion, it's very important that you are using your 4 labels. That way you know where to put your numbers at, and they're in the correct place when you're solving those proportions. And step 3, you can either try to simplify or solve the proportion the way that it is, either using the within or the between method. So let's go ahead and get started on some examples. So, example number 1, triangle ABC is similar to triangle DEF. Solve for X. So, using those 3 steps, we're going to solve this problem. So remember, the first step is that you want to draw the shapes correctly. If you notice, my triangles are not facing the same way. But I can use the statement given to me on top to figure out how to move my shape the correct way. Because I know that angle A would correspond with angle D. So A would correspond with angle D. I also know that angle B would correspond with angle E. So B would go with E. And then lastly, I know that angle C would go with angle F. And angle C is just my right angle. Here's my right angle. And so again, I want to try to redraw the bigger shape so that it's facing the same direction that ABC is facing in. So I'm going to redraw my shape here. Oops. And then when I redraw my shape, I'm going to go ahead and put in my angles so that I know that they are in the right place. So I know that A corresponds with D. So D has to be up here. I know that B corresponds with E. So E would have to be down here. And then lastly, I know that C, my right angle, corresponds with F. So my right angle would be here. Once I have redrawn my shape the correct way, I do want to go back in and put in the numbers that were around the shape. So from D to E, it's 15 centimeters. From E to F was 12 centimeters. And from F to D, it was 9 centimeters. So right now, I have redrawn my shape so that this shape is in the same position that this shape is in now. And then I know that this was my original shape. And then this one would be my new shape. So this is my new, this was my original. Okay, and so now I want to go ahead and move into step 2. I want to set up my proportion using my 4 labels. So for my labels, I'm going to use original and new because that's the name of my shapes. So original will be on one side and new will be on the other side. And then, let me fix that a little bit. I need to see what size do I want to use from my shape. Well, on my original shape, I have this part here. I have the height. So I'm going to say I want to use the height. So this over here would be my height. That's the corresponding side for my height. And then on my original shape, I also have this part here where X is at, which I know is called my hypotenuse. And then on my new shape, that would be my hypotenuse. And so for my ratios, I'm going to use hypotenuse as my last label. Now I'm going to go ahead and fill in the numbers that I know. So my original shape, what is the height of my original shape? It's 4.5 centimeters. For my original shape, what's the hypotenuse? When I come to the hypotenuse, I have the letter X there. I don't know what it is yet. For my new shape, what is my height for my new shape? It's 9 centimeters. Oops. And for my hypotenuse, for my new shape, it was 15 centimeters. And so now I want to try to see if I can solve the proportion the way it is set up right now by either using the within or the between method. And so what I notice is that I can actually work with the numbers I have here. I could try to simplify it as well, and I would still get the same solution. But I notice that there's a relationship here between the 9 and the 4.5. I know that 4.5 is half of 9. So my arrow is going to come this way because I always want to come towards my variable. I want to come towards the X because this is what I'm trying to solve. So I'm going to come down this way as well. And so to get from 9 to 4.5, what would I do? Well, I said that number is half of it. To get half of something, you basically divide that by 2. So remember, for the proportions, whatever you do to the top, you must also do to the bottom. So because I divided by 2 here, I have to divide 15 divided by 2. And so when I do 15 divided by 2, I get that X equals 7.5. So I just figured out that the hypotenuse for the original shape, X, equals 7.5 centimeters. And that's my solution. We're going to go ahead and do one more example, example number 2. And this one is a little bit different. So which pair of figures has a scale factor of 2.5? So they're giving me the scale factor of 2.5, and they want me to look at these answer choices and figure out which one used a scale factor of 2.5. So remember your definition for scale factor. It's basically the number you multiplied by to make a similar shape either larger or smaller. So there's 2 ways we can solve it out. The first one would be to just multiply the original shape times 2.5 and see if it gives us the new measurement. And remember the notation. The A by itself is telling me that this was the original or the pre-image, and the A prime with the apostrophe is my new image or my image. So I can either call it new or just image. This one would be my pre-image or my original. So they're telling me that to get this shape, I would have to multiply by 2.5. So if I did 3 times 2.5, I'm going to go ahead and key that into my calculator right quick. 3 times 2.5 is going to give me 7.5. So is that measurement over here 7.5? Well, no, that's not correct. So I know that my answer choice can't be A. Let's try answer choice B. What about 2? If I take 2 and I multiply it by 2.5, is that going to give me 6? Well, no, because 2 times 3 would give me 6, not 2 times 2.5. So I know that this is also not correct. Now for C and D, I'm going to go ahead and use the ratio method that we learned on Friday. So remember, the ratio method says that I take my new and I set it up over my original. So this is my new over my original. So I set up a ratio of 7.5 over 5. And all I do is put that into my calculator. 7.5 divided by 5 is going to give me 1.5. So is that the scale factor that we are looking for? Well, no, that's not correct. And so it has to be D, but let's double check. We're going to set up the ratio again with the new over the original. So new, 15, and 6 was my original. So again, I'm going to put that into my calculator, 15 divided by 6, because remember a fraction just means dividing. And that does give me 2.5, which is the scale factor that I was looking for. So my correct answer would be answer choice D. So again, remember for your scale factor, you do have two different ways that you can solve it. You can either just take the pre-image and multiply it by the scale factor to see if it gives you the new one. Or we can set up the ratio of new over original, divide this out, and see if we get the scale factor that was given to us.